Hello everyone, I'm Anna-Marie Ortloff and I'm happy to present to you today the results of our work on using nudges and boosts to influence web browsing privacy in a naturalistic environment. When we spend time online, and we're doing this a lot lately, our actions online leave traces and our behavior is tracked by the websites we visit as well as third parties. This leads to a loss of privacy and we can't control what happens to our data. In general, users are concerned about this, but that doesn't mean that they act that way and try to actively protect their privacy. This phenomenon is widely researched and known as the privacy paradox. There are technical solutions to protect one's privacy, such as deleting cookies, using privacy protective browser extensions, or using virtual private networks, among others. Since such technical solutions need to be adopted by users to actually have an effect, the basis of a solution to the privacy paradox is getting users to change their behavior. To achieve this sort of behavior change, we explored two strategies from the cognitive and behavioral sciences. Both of these are aimed at individuals, but they take different approaches to change behavior. The first strategy we investigated is nudging. Nudges exploit systematic cognitive biases to influence behavior by manipulating the choices users have without actually removing any choices and without including monetary incentives. A classical example is using defaults. A different type of nudge is one which compares a user to their peers or to experts and thus uses humans' tendency to be influenced by those around them. This is called a social nudge. The image shows an example of such a nudge, whereby one plan is designated most popular, so users assume it must be the best value plan since so many other people have chosen it previously. In the context of online privacy, social nudges, as well as using privacy indicators to nudge, have already been investigated. There are some ethical concerns with nudging, however, since it's not transparent for users that they're being manipulated. The second strategy we investigated, boosting, doesn't suffer from this limitation. Boosts aim to empower users to overcome their cognitive biases. They try to improve users' knowledge or skills to help them make better decisions. For example, boosts can teach users heuristics, such as that sites with a .gov or .org domain share less data with third parties than other sites. Other boost-like approaches presented information about websites' privacy policies in a more accessible manner. An early example of this was Privacy Bird, and more recently, contextual privacy policies were studied. We investigated two main questions. First, how do the two strategies compare in helping users reach more online privacy? And second, do boosts change users' knowledge? Since nudges work by subconsciously influencing users, we didn't expect them to change knowledge. Hence, the focus is on boosts in the second question. Since it's crucial that boosts are understood by users, we pre-tested them with an online survey with a between groups design with one condition per boost and an additional control condition. The information for boosts came from the literature and they were simple facts, for example, concerning which website type had more or less cookies in tracking, or regarding the additional privacy protective functionality of features like ad blockers in the example above, or browser settings. A total of 127 participants took part and answered questions which required them to use knowledge from boosts presented to them previously. Depending on the boost, this could be multiple choice questions where participants had to select a number between 0 and 10, or true-false questions. To check boost understanding, we conducted Wilcoxon rank sum tests on the results. The lower graph shows the percentage of correct answers, while the upper right graph shows deviations from correct answers. This means that in the lower graph, if the manipulation condition, which is depicted in orange, has higher values than the control condition in blue, boost knowledge was successfully applied. Since the upper graph shows deviations from correct answers, it's the opposite. And smaller values in the manipulation condition mean that boost knowledge was applied correctly. There was a significant difference between the control group and each of the boost groups except for one, which was the third-party reduction boost. However, this might have been due to presentation issues with the questions, so we deemed all boosts suitable to use in the naturalistic follow-up study, except for the news boost, which we removed for ethical reasons, since heeding to its advice might lead users into a filter bubble situation, which would not be a good outcome for them. Now that we know that boosts are understood by users, we can compare the effect of boosts and nudges on online browsing privacy. Since nudges work by subconsciously influencing users, it wasn't necessary to pretest them for comprehension. Now let's look at the experiment design for our naturalistic study. We designed a naturalistic experiment using a browser extension. That way, participants' behavior could be observed in their natural environment. That's to say, while they were using their own browser. This is in contrast to previous, more controlled lab-based work, for example by Zimmerman et al. To learn about users' behavior, we collected information on the change to cookies and the number of third-party requests per website, which were used as proxies for browsing privacy in previous work. We also categorized the visited websites to preserve participants' privacy by not identifying the actual websites participants visited, and we collected some information on privacy-related settings. The participants were allocated to one of 3 conditions and used their browser with the browser extension installed during 3 weeks. The first and third week of the study were control periods. During the second week, participants were exposed to either nudge or boost interventions. There was also a control group, which did not see any intervention during the study. Boosts simply presented the facts we evaluated earlier. And nudges utilized in the study were social nudges, which compared a participant to the other participants in the study, concerning different metrics representing browsing privacy. These were the average change in the number of cookies per website and the average number of third-party requests, both of which I previously introduced as proxies for browsing privacy. And to make the number of nudges and boosts equal, we used additional metrics which were derived from these two, for example, the privacy points seen in this nudge. During the second week, an intervention was presented to participants once per day, for those in the boost or nudge groups. Of 78 users who registered for participation beforehand, 68 actually filled out the questionnaires at the start of the study, and there's behavioral data for 1 additional person. There were some dropouts during the study, so that at the end, 60 people filled out the questionnaires, among them a demographic questionnaire. In total, there were 25 users each for the boost and nudge conditions, and 19 users for the control condition. The numbers in parentheses behind are those users which were still participating at the end of the study. Let's now look at user behavior when exposed to boosts or nudges. Website usage, which in this case means the number of websites visited per day per user, was relatively similar across all 3 groups during the different phases of the study. Other usage data, like the number of people who actively use their browser on a given day during the study, was also similarly distributed along groups, although there was slightly less usage on weekends and towards the end of the study. Since the privacy paradox in part motivated this work, we were interested in its presence in our data. We first conducted a Poisson regression using privacy knowledge and privacy concerns as the independent variables, and the number of privacy protective actions reported by participants as a dependent variable to explore this. The privacy protective actions we asked for were, for example, using do not track setting, a virtual private network, or a privacy protective browser or search engine, among others. And we counted the number of privacy protective actions that participants reported. Both of the independent variables and their interaction were significant predictors of the number of privacy protective actions, so in that regard, the privacy paradox didn't appear in these data, since the higher participants' concern and knowledge, the more actions they took to protect their privacy. Since self-reported behavior may not be accurate, we also conducted multiple regression analyses to predict the proxies for browsing privacy as traces of behavior with the same predictors. These analyses did not yield significant results and thus suggest a confirmation of the privacy paradox. However, it should be considered that participants did not see the measures we tried to predict and could only indirectly influence these measures for browsing privacy. To find out whether the interventions help users achieve more privacy, we conducted aligned rank transform analyses, which are a non-parametric alternative for repeated measures ANOVA. We performed 2 of these analyses using both proxies for browsing privacy as a dependent variable. In both cases, there were significant effects, both for study phase and condition, but not for their interaction. In post-hoc tests, week 1 and week 2 differed significantly, as well as week 1 and week 3, but not week 2 and week 3. And there were no significant differences between conditions in post-hoc tests. Looking at the graphs displaying means and 95% confidence intervals, we can see that for the average change in cookies, the nudge group displays an improvement from the first to the second week, and then a little less evidently to the third week. But the boost and control groups stay largely the same. For the number of third-party requests, nudge and control groups are similar, but the boost group displays an improvement from the first to the second week. However, there was a lot of variation in the values for the first week for the intervention groups, so it's not clear to us what the cause for this is, as there were no significant differences, for example, in the numbers or types of websites visited between the groups. So this may also be an artifact of a small sample. To study the change in boost knowledge, we conducted an ANOVA to determine the difference between boost knowledge pre- and post-study for different groups. This visualization shows that in all 3 conditions, there were people whose knowledge improved, declined, and didn't change. As such, there was no significant difference in knowledge change between the groups. This is contrary to the online survey, where knowledge was higher for those participants exposed to boosts. Thus, boosts were able to improve knowledge short-term, but not long-term. This work encompasses a survey to evaluate boost comprehension and to select boosts using crowdsourcing. These were then used together with social nudges to explore the effect of both strategies on browsing privacy in a naturalistic experiment. We found that boosts improved participants' knowledge in the short term, directly after exposure, but not in the long term, over a week after exposure. Browsing privacy was improved during the intervention period for both boosts and nudges, regarding different measures. Although these results must be judged in the light of our largely student sample, as well as that in trying to provide an ecologically valid study environment, we had little control over participants' interactions with our interventions. We provide material like the browser extension code and the questionnaires we used on GitHub for the community. Finally, I'd like to thank my co-authors for all their guidance and assistance, and the SIG IR for funding my attendance here at this year's cheer through a student travel grant. Thanks for your interest so far, and I'm looking forward to your questions and discussion later.